Good morning to one and all. I am Dr. Jaganmohan Janalagat. So, we are in the 15th lecture of Advanced Statistical Methods. The course number of our course is Ba Zg524. So far, we have learned different statistical methods. So now we are in the last lecture of our course. The next lecture I am going to revise all those problems which are important for our comprehensive examination. That will be scheduled next week. So in that class we will revise all those problems which we can solve or which are important for comprehensive examination. So now we are left out with only few topics. So whatever the topics that I am going to deal with today, they require software packages to solve the problems. So that's why I'm only giving you an outline of these methods, and we are not going to solve any problem because without a software package we cannot complete these. So that's why I'm giving you an outline of these methods and we'll close the syllabus. So we'll start with a concept called discriminant analysis. So the name itself says that we are going to discriminate something. That's what. So I'll give an example. A study of 294 consumers was undertaken to determine the characteristics of consumers who respond favorably to direct mail promotions that offer a discount on the normal purchase price. So this is our objective. So the predictor variables were four factors related to household shopping attitudes and behavior, and selected demographic characteristics that are gender, age and income. So we have four independent variables, and the dependent variable was the extent to which respondents were predisposed to take up the offer of a rebate, of which three levels were identified. So here the dependent variable is a categorical variable with three different levels. So respondents who reported no purchases triggered by a rebate during the past 12 months were classified as non-users. Those who reported one or two such purchases as light users, and those with more than two purchases as frequent users of discounts. So here the dependent variable is a categorical variable with three levels. So multiple discriminant analysis will be used to analyze the data. So how do we do that? In this example, we will calculate the intergroup differences. After calculating intergroup differences, the significant intergroup differences were found using multiple predictor variables. So an examination of differences across groups lies at the heart of basic concept of discriminant analysis. So the question is like, on the whole, the interesting point behind the concept of discriminant or linear discriminant analysis is that here the dependent variable is categorical variable, whereas the independent variable be anyone. Okay. So what is discriminant analysis? Discriminant analysis is a technique for analyzing data when the criteria or dependent variable is categorical and the predictor or independent variables are interval in nature. Interval means numeric, right? So in this technique, the predictor variable are interval in nature and the dependent variable is categorical. So let us discuss in which of the following following cases we can use discriminant analysis. So in terms of demographic characteristics, yes. In terms of demographic characteristics, how do customers who exhibit loyalty to a particular car manufacturer differ from those who do not? So in these type of situations, you can find, do heavy users, medium users and light users of soft drinks differ in terms of their consumption of frozen food? What psychographic characteristics help differentiate between price sensitive and non-price sensitive buyers of groceries? What are the distinguishing characteristics of consumers who respond to direct mail offers? So, the first example, the categorical variable or the dependent variable is exhibiting loyalty and not exhibiting loyalty. In the second example, heavy users, medium users and light users are your dependent variable. In third example, price sensitive and non-price sensitive buyers are your dependent variable. And in the fourth example, different characteristics just not observed in the previous example. So we can finalize like this: in discriminant analysis, dependent variable is categorical variable. So what are the objectives of the discriminant analysis? So what we will do there? So first of all, you have to construct a discriminant function. So like if there are only two categories, maybe one discriminant function. More than two categories, the respective discriminant functions you have to construct. What are discriminant functions? They are the linear combinations of the independent variables, which will best discriminate between the categories of the dependent variable. So the first objective of discriminant analysis is you have to construct a discriminant function if there are only two categories in your dependent variable, or k minus 1 discriminant functions if there are k categories in your dependent variable. What is the use of this discriminant function is like it discriminates the difference between different groups or different categories of the predictor dependent variable. So the next one is examining whether these significant differences exist among the groups in the terms of predictor variables. Then determination of which predictor variable contribute most to the intergroup differences, means the differences between the groups, and classification of cases to one of the groups based on the values of the predictor variable, and evaluation of the accuracy of classification. So these are the steps involved in discriminant analysis. But at the end of the method, what we have to identify is that which category discriminates more than the others. Discriminant analysis techniques are described by the number of categories possessed by the criterion variable. That's what I'm telling you. Like when the criterion variable or dependent variable has two categories, the technique is known as two-group discriminant analysis. When three or more categories are involved, the technique is referred to as multiple discriminant analysis. So the main distinction in that is the two-group case. It is possible to derive only one discriminant function, but in multiple discriminant analysis, more than one function may be computed. That's what I'm telling you. So then you can think about what is the difference between the ANOVA, regression and discriminant analysis. So if you compare them, even you can compare with logistic regression also, because that is also one type of things we have learned, if you remember properly. So let us compare ANOVA, regression and discriminant analysis. I will also try to compare with logistic regression. So first of all, we'll compare the similarities. After that, we will compare the difference. So similarities, I am comparing two characteristics, the number of dependent variables and number of independent variables. Whereas in differences, I am taking two characteristics, nature of the dependent variables and nature of the independent variables. So for ANOVA, number of dependent variables is 1 and number of independent variables is multiple. And for regression and discriminant analysis also the same holds. So this is the common property of all the three analysis techniques. Whereas if you compare to the nature of the dependent variables, in ANOVA it is metric, that is interval or ratio scale. In regression it is also metric, and in discriminant analysis the dependent variable is categorical. Now if you come to nature of independent variables, in the ANOVA it is categorical, in regression it is metric, and in discriminant analysis it is metric. Whereas if you take a logistic regression, nature of dependent variable is again a categorical, and nature of independent variable may be either categorical or metric. It can be any one. That's what we have done in logistic regression. So we'll explain the differences between these three by a simple example. So we explain these relationships with an example in which the researcher is attempting to explain the amount of life insurance purchased in terms of age and income. So the amount of life insurance purchased is your dependent variable and age and income are your independent variable. All three procedures involve a single criteria dependent variable and multiple predictor or independent variables. But the nature of these variables differ, however. In ANOVA and regression analysis, the dependent variable is a metric or interval scale because you are talking about the amount of life insurance purchased, this amount. Whereas in discriminant analysis, it is categorical. Amount of life insurance purchased can be classified as high, medium, and low. The independent variables are categorical in the case of ANOVA because age and income are each classified as high, medium, and low. But metric in the case of regression and discriminant analysis. Age in terms of years and income in terms of euros. So this is the clear understanding between these three, the similarities as well as differences. So I'm giving you, or I'm concentrating only on discriminant analysis with two categories of dependent variables. When there are only two categories in dependent variable, you will have only one discriminant function needs to be constructed. So the discriminant analysis model is a linear combination of independent variables. So it can be taken as a form of D equal to B0 plus B1 x1 plus B2 x2 plus and so on Bk xk, where D is the discriminant score, B's are discriminant coefficients or weights to be calculated, X's are predictor or independent variables. So this is the discriminant analysis model. So we have to estimate B's. That's what the idea. So generally the outline of the discriminant analysis is step 1, you have to formulate the problem. Step 2, estimate the discriminant function coefficients. Step 3, determine the significance of the discriminant function, interpret the results, and finally access the validity of discriminant analysis. So let us discuss these steps in detail. Conducting discriminant analysis, first step is formulating the problem. So the first step in discriminant analysis is to formulate the problem, that is identifying the criterion and independent variable. So the criterion variable must consist of two or more mutually exclusive and collective exhaustive categories. Of course, the dependent variable may have two or more categories. The predictor variable or the independent variable should be selected based on a theoretical model or previous research. The next step is to divide the sample into two parts. One part of the sample is called the analysis sample, which is used for the construction of discriminant function. And the other part is called the validation sample, which is used to validate the discriminant function. So you have to repeat the process continuously. So these are the outlines of discriminant analysis which we are discussing now. So in discriminant analysis, you should remember that here we have only one dependent variable with several categories and many independent variables. They are metric in nature. Okay. Now we'll move to factor analysis. So let us go through the example. No, we don't have any solved problems because the question is like we need software. I cannot explain just by showing the numbers. If we run it only, then we can understand. So I suggest you just understand the method. So let us go to factor analysis. So in a study of personal alarms, women were asked to rate 8 personal alarms using the following 15 statements. Means I am giving you many factors in which you have to take only 8 which covers all. That's what the logic. So I have given almost 15 statements called as 15 factors which are influencing or affecting the things, in which I am asking you to select 8 which covers all. So feels comfortable in the hand, could be easily kept in the pocket, would fit easily into a handbag, could be easily worn on the person, could be carried out to be very handy when needed, could be set off almost as a reflex action, would be difficult for an attacker to take it off me, could keep a very firm grip on it if attacked. An attacker might be frightened that I must attack him with it, would be difficult for an attacker to switch off, solidly built, would be difficult to break, looks as if it would give off a very loud noise. An attacker might have second thoughts about attacking me if he saw me with it. I would be embarrassed to carry it around with me. So these are the 15 personal alarms in which we have to choose 8. So the question was simple, very simple to understand factor analysis. Could these 15 variables be reduced to a smaller number of derived variables known as factors in such a way that too much information was not lost? Means without losing too much information, I have to reduce the number of factors. So that's why factor analysis means reducing to a less number of variables without losing much information. So factor analysis enabled these 15 variables to be reduced to 4 underlying dimensions or factors that women used to evaluate the alarms. Factor 1 seemed to measure a dimension of size on a continuum of small to large. Factor 2 tapped into aspects of the appearance of a personal alarm. So first one is dimension, second one is appearance. Factor 3 robustness of characteristics of the alarm, and 4 hand feel. So if you take only these 4 factors, then most of these 15 factors will be fitted into these 4. So the concept of factor analysis is just maybe you have to reduction the dimensionality. That's it. So what is factor analysis? Factor analysis is a general name denoting a class of procedures primarily used for data reduction and summarization. Just we are reducing the dimensionality of the problem. In marketing research, there may be a large number of variables, most of which are correlated and which must be reduced to a manageable level. So relationships among sets of many interrelated variables are examined and represented in terms of a few underlying factors. So after studying these many relations, we will only reduce to a few factors which underlie all these relations. So if you compare with the analysis of variance, multiple regression and discriminant analysis with factor analysis, the interesting thing is that here there is no concept of dependent variable and independent variable. That is the one important point to remember. In analysis of variance, multiple regression and discriminant analysis, one variable is considered the dependent or criterion variable and the others are considered as independent or predictor variables. But no such distinction is made in factor analysis. Rather, factor analysis is an interdependence technique in that an entire set of interdependent relationships is exact. So here there is no concept of independent variable and dependent variable. We will take all factors and we will discuss their interrelationships. That's what the important point. So in which circumstances we can use factor analysis? So to identify underlying dimensions or factors that explain the correlations among the set of variables. So from a given set of variables, you have to identify the underlying factors which covers all. For example, a set of lifestyle statements may be used to measure the psychographic profiles of consumers. These statements may then be factor analyzed to identify the underlying psychographic factors. Maybe. Then next, to identify a new smaller set of uncorrelated variables to replace the original set of correlated variables in subsequent multivariate analysis. Instead of having many correlated variables, we will make them a smaller set. For example, the psychographic factors identified may be used as independent variables in explaining the differences between loyal and non-loyal consumers. This maybe comes under discriminant analysis. To identify a smaller set of salient variables from a larger set for use in subsequent multivariate analysis. For example, a few of the original lifestyle statements that correlate highly with the identified factors may be used as independent variables to explain the difference between the loyal and non-loyal users. So like this, you can subsequently you can use these things in a different ways also. So what are the applications? So factor analysis can be used in market segmentation for identifying the underlying variables on which to group the customers. New car buyers might be grouped based on the relative emphasis they place on economy, convenience, performance, comfort and luxury. This must result in 5 segments: economy seekers, convenience seekers, performance seekers, comfort seekers and luxury seekers. So these are the 5 underlying factors which can be used finally. So whatever the variables first we decide, finally we can reduce them into these 5 underlying factors. In product research, factor analysis can be employed to determine the brand attributes that influence consumer choice. Toothpaste brands might be evaluated in terms of protection against cavities, whiteness of teeth, taste, fresh breath and price. So maybe there may be many variables initially, but finally these 5 factors are the underlying one. In advertising studies, factor analysis can be used to understand the media consumption habits of the target market. The users of frozen foods may be heavily viewers of satellite TV, see a lot of videos and listen to country music. This may be finally the last underlying set of variables. In pricing studies, factor analysis can be used to identify the characteristics of price-sensitive consumers. For example, these consumers might be methodical, economy-minded, and home-centered. Maybe these are the final list of underlying factors after analyzing all the collected variables. So what will be the general factorial analysis model? Mathematically, each variable is expressed as a linear combination of underlying factors. So the covariation among the variables is described in terms of a small number of common factors plus a unique factor for each variable. If the variables are standardized, so you'll have a mathematical model like this. So what is the concept of factor analysis? So just formulate a problem, construct the correlation matrix, then apply the method of factor analysis, then determine the number of factors, and finally rotation of factors and interpretation of factors and determination of model fit. So what are the important points is the object of factor analysis should be identified. That is the first point. The variables to be included in the factor analysis should be specified based on past research, theory, and judgment of the research. It is important that the variables be appropriately measured on an interval or ratio scale. That's an important one. And an appropriate sample size should be used. So these points we should remember in factor analysis. So at the end of this slides, I can say one thing. Factor analysis is nothing but like for a given concept, maybe there may be many relationships or variables may exist. You have to reduce the dimensionality by identifying the underlying factors. That's what the concept of factor analysis. I'll take a small break and I'll close the last one, cluster analysis. In order to achieve an expanded customer base, Haagen-Dazs identified potential consumer segments that could generate additional sales. It used geodemographic techniques which are based upon clustering consumers clustering consumers using geographic, demographic, and lifestyle data. Additional primary data were collected to develop an understanding of the demographic, lifestyle, and behavior characteristics of the Haagen-Dazs cave users, which included frequency of purchase, time of day to visit cave, day of the week, and a range of other updates. With a postcode or a zip code, respondents can be assigned to one of the arrays of established geodemographic classification. Haagen-Dazs compared its profile of customers with the profile of geodemographic classifications to develop a clear picture of the types of consumers it was attracting. From this, it decided which profiles of consumer or target marks it believed to hold the most potential for additional sales. So which means that they are clustering, they are forming the groups based on the geodemographical data. So from which one can easily identify the preferences of the customers. So what do you mean by cluster analysis? So cluster analysis is a class of techniques used to classify objects or cases into relatively homogeneous groups called clusters. So just we are classifying the data in form of clusters. Objects in each cluster tend to be similar to each other and dissimilar to objects in the other clusters. Cluster analysis is also called as classification analysis. So here we are forming groups of homogeneous data. Both cluster analysis and discriminant analysis are concerned with classification only, because in discriminant analysis also we are classifying based on the categories of dependent variables. However, discriminant analysis requires prior knowledge of the cluster or group membership for each object or case included to develop the classification. In contrast, the cluster analysis, there is no a priori information about the group or cluster membership for any of the objects. It can be just clustered by the given data. So this is the ideal clustering situation where in each group we have a homogeneous data, and when we compare the data with other group, they must be inhomogeneous. But this is a practical situation from a data we are plotting it. So what is the procedure of cluster analysis? Just formulate the problem. Just select a distance measure to calculate the distance between the clusters. Select a clustering procedure. Decide on the number of clusters. Interpret and profile clusters and assess the validity of clustering. So we'll go with one by one step. So the steps involved in conducting cluster analysis are listed in the above figure. So what is the first step? Formulate the clustering problem by defining the variables on which clustering will be based. So means on what basis we are clustering your data. Then an appropriate distance measure must be selected. What is the distance measure? It calculates the distance between the clusters. Several cluster procedures have been developed, and the researcher should select one that is appropriate for the problem, which is not relevant here. Deciding on the number of clusters requires judgment on the part of the researcher. And the derived cluster should be interpreted in terms of the variables used to cluster them and profiled in terms of additional salient variables. Finally, he has to assess the validity of the clustering process. So these are the steps involved in conducting cluster analysis. So identifying the variables on which clusters has to be formed, finding a measure for the distance between clusters, appropriate clustering method, ideal number of clusters, and validity. So how to formulate the problem and how to identify variables on which clusters are based. Perhaps the most important part of formulating the cluster problem is selecting the variables on which the clustering is based. So if you include two or more irrelevant variables, then we may not have a perfect solution. That's why you have to choose properly the ideal variables on which the cluster should be based. Then you have to select a distance or similarity measure between clusters. The most ideal are Euclidean distance measure. You know what is Euclidean distance. Then the next Manhattan distance, and the third one is Chebyshev's distance. So Euclidean distance means the square root of the sum of the square differences in values for each variable. Manhattan distance means it is the sum of the absolute differences in values for each variable. And Chebyshev's distance means is maximum absolute difference in values for any variable. So we have three types of distance measures. Not only these three, we have several, but these are the three popularly used measures. Like for example, if you have like this 1, 2, 3, and 4, 5, 6. If we have two like this, then correspondingly Euclidean distance means 1 minus 4 whole square is 9 plus 2 minus 5 whole square is 9 plus 3 minus 6 whole square 9 under square root, that is square root of 27, which is Euclidean distance. Manhattan means 1 minus 4 is minus 3 mod, so it's 3 plus again mod 2 minus 5 3 plus again mod 3 minus 6 3. So 9 is the Manhattan measure. What is Chebyshev's? Chebyshev's is you have to calculate the maximum of mod 1 minus 4, mod 2 minus 5, and mod 3 minus 6. So what is the maximum? 3. So like that you can calculate these distances easily. So Euclidean distance, square root of sum of squares of the differences. Manhattan, sum of the absolute differences. Chebyshev, maximum of absolute difference. Yeah, of course, right. You have to first of all select a variable. Based on that you can give clusters. Now even you can treat a categorical variable as a metric by giving 0. Yeah, that's what 0 1 type of binary classification you can give for categorical data. So it's not a problem, right? So we have done these type of things using a dummy variable technique in regression analysis. So that's why you can classify like that. So maybe, yeah, marriage characteristics can be classified as one cluster, age characteristics can be classified as one cluster, marital status can be classified as one cluster. Maybe that based on that we can do that. So yes, Fine then. Yeah, if you have any queries, you ask me. So I'm unable to solve any problems of these three methods because I told you again and again that I need a software package on which I can run this. So that's why I have given the outline of these methods, like what they are for and what they are and what we need to do in that. So we started with discriminant analysis. I told you in discriminant analysis we are having a categorical variable as dependent variable and metric variables are independent variables. So suppose if we have two categories for a dependent variable, then you have to construct a discriminant function based on the independent variables. And based on this discriminant function, you have to identify which category has more significance. Similarly, if you go to a factor analysis, it's nothing but just by observing, you have to reduce the dimension of the data. And cluster analysis, you have to cluster the data based on the objectives. Yes. So that's what we have. So if you have any queries regarding this course, you please let me know. And what I am planning is that I am going to solve important models of problems in the next tutorial, sorry, in the next lecture, which completes even the revision also. So I'm only concentrating on those problems or models which are important for our comprehensive examination so that you can easily solve the question. Any other queries? Yeah, please, if you have any questions in the assignment, anyone can ask me if you have any assignment. What is the problem? So we have done forecasting in the last class. In the last class, we completed forecasting. Yes. Okay. Okay. So the things which we have done, these you are telling that they are not in our syllabus. Is it so? So let me give a couple of days time. Maybe I'll just go through it one more time. Thanks for the information. I'll just go through those questions and I'll edit them for your convenience. Is it okay? Yeah. Thanks for the information. Yeah, you have identified and thanks for the clear observations of the questions. Maybe I have skipped it by my mind. I understand. These explanations are not there in our syllabus. I understand that. Thanks for that. I'll just go through it and I'll just slightly change the question in what way we need, and the same thing I'll upload the questions. Okay, for this assignment. Yeah. Just mail me if uh, just mail me. I'll mail my. Okay. Yeah. So I'll remember this group 10 project and I'll slightly edit. If any others also having the same problem in their assignments, please let me know. Sure, sure. You can do that. I want to tell you one thing. Don't be panic regarding the questions which we are going to solve in the exams. Like, we will give what we have discussed in the lecture at the same time as like a plain questions, not too confusing or not too critical. Like, it's based on the concept, but you can easily answer it. Sure. And finally, anyhow, the last lecture which we are going to discuss is the problems which are important for our company. And based on those, you prepare as many as you can and ask me doubts. Is it okay for you? Okay. Yeah. Then thanks for today. If any queries, please mail me. I'll always be in your assistance for that. Thanks. Yeah. Thank you. Have a good day. Yes. Uh, the next class I told you only revision of problems important for our company. Yes. Next Sunday we have a revision class of all problems important for our comprehensive exam.